All right, here we go. Another quadratic word problem. I'm going to try to do this one a little bit faster than the last one because I only got about 4.5 minutes before the bell rings. So we're going to try to fit it in that. Again, we're focusing on the same issues. What is the question being asked and what is the information being given to me? All right, so let's go with, you can read the problem. I'm not going to read it for you. Let's go to question A. What height does the brush start from? So what is it asking? It's asking for a height. Okay, so we're looking for height. That means that h should be the variable, which means I should be given some information about t. And sure enough, it tells me start. At the start, what is t? T equals 0. So I have t equals 0, so I should be able to just go h equals negative 10 times 0 squared plus 10, which is 10. So 10 meters. All right, so it starts at a height of 10 meters. Let's go on to letter B. What evidence in the problem leads you to draw the conclusion you came to in part A? Well, note that he's on a ladder, so he's got to be pretty high. Note that this is a quadratic that has a constant term on the end, and the last term is always the y-intercept. And so really that's enough to kind of reason through. The start is times 0, therefore the y-intercept, or the y value at the beginning, is 10. Letter C then asks for the significance of the starting height on the graph, and we've already said this a couple of times. It's the y-intercept. Why? Because t is representative of our independent variable, which is x. This thing over by itself, remember f of x, back in the day, f of x is the same thing as y. All right, because the height depends on the time. As time passes, the height is going to change. All right, so that would be the y-intercept, which is not letter B, but letter C. Let's go on to letter D. At what times will the brush be on the ground? All right, so here it's asking me what time. What information is it giving me? On the ground. Right? So looking for these key words, what time on the ground. So since it's asking for time, my equation better still have a t in it, because that's what I'm going to solve for. That's what I'm going to find. Now, on the ground, right? On the ground means that the height is going to be 0. So we're just going to go 0 equals negative 10t squared plus 10. And so then you just take that and you can solve it. You can use factoring, you can use quadratic formula, however you want. I used factoring last time, so let's go ahead and use quadratic formula to work it out. And so I'm just going to pause it, show you the quadratic formula and the answer. You can check it yourself if you want right now. You can work it out. Go ahead, pause your video. So there you go. Quadratic formula, wham, is done. So I got x equals 1 and x equals negative 1. The question is asking what time will the brush be on the ground. Well, negative 1 second doesn't really make sense. So 1 second would be the answer. So 1 second. All right, then we go on to letter E. How long will it take the brush to fall to the ground from the shelf? Well, it was on the shelf at time 0. It got to the ground in 1 second, so E again is 1 second, is how long it takes it to fall that 10 meters. All right, what point on the graph represents the time when the brush hits the ground? All right, so what point on the graph hits it? Okay, so that is just what we did here. You made y0, and when you make y0, what are you solving for? You're solving for the x-intercept. Wham! Less than 4.5 minutes. Congratulations, me. That's it. Watch another one if you want.